going to talk about what we call the sign of a quadratic. It uses the discriminant that we looked at yesterday. There's a term called positive definite. There's an example of a positive definite curve. Now the reason it's called positive definite is it doesn't matter what x value I substitute into the equation as parabola, the answer will definitely be positive. So basically we're talking about a parabola that's always above the x-axis. So the conditions for a curve to be positive definite, well, it would have to be concave up, and the discriminant would have to be less than 0 because it can't cut the x-axis. So both of those conditions would have to be satisfied. And if we know that, then we know the answer will always be positive when we substitute in. And it has a corresponding one, negative definite, which would be concave down, but again this time it's always below the x-axis. So it wouldn't matter what x value we substituted into that parabola, we'd always get a negative answer. So that one's negative definite. So the only difference there is the concavity is down. So A is less than 0. Discriminant is still less than 0 because it still doesn't cut the x-axis. They're really the two main terms. There used to be terms which we don't really use anymore called positive semi-definite and negative semi-definite, and that was when it just touched the x-axis. But we don't seem to worry about those anymore. It's really positive definite or negative definite. Anything else we just call indefinite now. So that's an example of an indefinite curve where it just touches. That would have concavity going up and discriminant equals 0. That one's also indefinite. That one's got concavity going down, discriminant equals 0. That one's definitely indefinite, if that's possible. Definitely indefinite. Because sometimes it's positive, sometimes it's negative, sometimes it's 0. So that one's concave up, discriminant greater than 0. And that one also, sometimes it's positive, sometimes it's negative, sometimes it's 0. But that one's concave down. And so we very rarely worry about indefinite. The concavity is irrelevant when it's indefinite. All you really have to worry about is the discriminant being greater than or equal to 0. So basically, it touches or cuts the x-axis. But the vast majority of questions, they'll simply ask, is it positive definite or negative definite? Questions like this. So there's a quadratic, but we've got to work out the values of k that would make that positive definite. So it has to satisfy two conditions. First of all, a has to be greater than 0. So in this case, I know k has to be a positive number. But also, the discriminant has to be less than 0. So b squared minus 4ac must be less than 0. If I solve that one, I get k squared is greater than 9. So k is less than negative 3, or k is greater than 3. But both conditions must be true. So we said k had to be positive. So therefore, the only possibility is k is greater than 3. The less than negative 3 doesn't work. So we'll add 8g to our list of questions to look at.